Hello, my name is Sumit Kadasinganahali, and for my interesting mathematics project, I have the Monty Hall problem. So let's check it out. So a basic review of the Monty Hall problem. The Monty Hall problem is a problem that's all about random selection and probability. So the main objective in this problem was that there are three doors, and out of the three doors, you had to try to pick the one that had the prize behind it. But the main problem a lot of contestants encountered with this problem is that when the host revealed a door, they couldn't figure out whether they should keep the door that they originally selected or switch to the door that hadn't been revealed yet. And as we see, over time it was proven that switching doors gave you a mathematically higher chance of winning than if you picked your original door. And we'll see that later as to why that is. So the background of the Monty Hall problem is that this was first seen in 1975 when on a game show, Let's Make a Deal, host Monty Hall had people play a game of choice. So the contestants were told that there were three doors, and one door had a prize that they really would want, but then the other two doors had items that they wouldn't want at all. So they had to pick a door, and once they selected a door, Monty would go over to another door that he knew had a bad item and he would reveal it to the contestant. And this is where the contestants faced a tough choice. They had to see whether or not they wanted to keep the door they originally selected or switch to the other door that hadn't been revealed. And so when the math behind it was revealed, there became a lot of dispute about whether switching doors actually did give you a higher chance of winning or not. But as we see later, it does give you a higher chance mathematically. So the Monty Hall problem's importance to mathematics is that it shows us a completely different view about probability. It shows us that not only a single action, different single actions have different probabilities, but it shows that compounding actions can result in different probabilities than just a single action. So for example, if a contestant picks door 1 and the host opens doors 2 or 3, the prize has a 1/6 chance of being behind door 1, or the door that the contestant has picked. However, if the contestant picks door 1 and the host opens door 3, then the prize has a 1/3 chance of being behind door 2, or the door that the contestant hasn't picked, which shows that if you switch doors, you double your chance of winning rather than keeping your original door. And that shows us that the compounding action of the host revealing a door to us increases our probability of winning, knowing that if we switch doors, we double our chances of winning. Finally, we get to the explanation of the mathematical reasoning behind the Monty Hall problem. So first of all, if a contestant picks door 1, then the host can either reveal doors 2 or 3, and that depends on where the prize is. But if a contestant picks door 2, door 3 has to be revealed, and that applies to if door 3 is selected, then the host has to reveal door 2. So let's take this scenario. If the prize is behind door 1 and the contestant also selects door 1, let's say the host opens door 3, but the host can also open door 2, and the probability of that is 1/6. However, if the prize is behind door 2 and the contestant selects door 1, the host has to open door 3 because that's the only door that really hasn't been selected in any way. And the probability of that happening is 1/3, which is double the probability of the previous situation. So this shows that the probability of the host opening door 3 because the prize is behind door 2 is double than the probability of the host opening door 3 because the prize is behind door 1. So if the contestant selected door 1, they have almost a double chance of winning if they switch to door 2 than if they keep their original door and stay at door 1. and that's why switching doors is the better option than keeping your original door in the Monty Hall problem. So in conclusion, in the Monty Hall problem, switching doors is the better option because mathematically your chance is double of winning than when you switch doors than if you keep your original door. And the key to success in the Monty Hall problem is paying attention to how the host manipulates the doors by carefully paying attention to what door they reveal and then figuring out, okay, if they reveal that door, then there's got to be a reason as to surrounding that, and then you have to know um which door has a more likely chance of having the prize based on the door that the host reveals. Thank you for listening to this PowerPoint. I hope you learned a lot about the Monty Hall problem, and next time you find yourself on a game show, you can use this PowerPoint and refer to this knowledge to help you get a better chance of winning. Thank you.